Welcome, everyone. Today, we're going to talk about a major paradigm shift in search technology. Search has a brand new primary user, and it's time we build retrievers that actually understand them. We're introducing AgentIR, Reasoning-Aware Retrieval for deep research agents. Let's start with the fundamental shift happening in the search user base. In the past, human users would type out isolated, often ambiguous queries into search bars without documenting their thought processes. But today, deep research agents operate very differently. Before an agent even makes a search call, it generates an explicit, natural language reasoning trace to explain its thought process, mapping out its exact objective and the steps needed to get there. The problem is that conventional retrievers suffer from a massive blind spot. Existing search systems treat these highly detailed agent queries exactly the same way they treat standalone human searches. As a result, they completely ignore the rich intent, the reflection on prior search results, and the hypotheses that are clearly written out in the agent's explicit reasoning. So, what is the solution? We call it Reasoning-Aware Retrieval. This is a brand new retrieval paradigm that directly embeds the agent's reasoning trace alongside its search query. By doing this, we can leverage the rich intent and context that the agent is already generating, entirely free of charge, during its standard operating React loop. Let's look at exactly how this reasoning transforms an ambiguous query. Imagine an agent issues the query Backroom Studio early 2010s euphoric. A conventional retriever sees this and pulls up a generic, completely irrelevant document about video game studios. But AgentIR looks at the agent's reasoning trace, which reveals the agent is actually looking for a Swedish progressive house artist who won a Grammy. By embedding this reasoning, our retriever instantly narrows the search space and finds the correct, highly relevant document about the target artist, Otto Knows. To build this, we faced a major data bottleneck when training for multi-turn intent. We found that off-the-shelf embedding models just aren't optimized to properly weight these reasoning traces. The root of the issue is a lack of training data. Existing datasets are built for single-turn humans, meaning we completely lack the subquery level relevance labels required for contrastive learning. To overcome this missing data, we built DR-Synth, a novel data synthesis pipeline. DR-Synth takes standard, single-turn QA datasets, like WebShaper, and transforms them into highly specific, multi-turn agent training instances. It leverages agent rollouts to automatically generate pairs of agent subqueries and their corresponding relevance labels. How do we get accurate relevance labels for these intermediate steps? We use a process called Oracle re-ranking. First, DR-Synth retrieves the top 50 documents using a query-only baseline. Then, it prepends global gold documents known to be relevant to the overall objective. Next, it prompts a large language model to perform list-wise re-ranking. This isolates the documents relevant to the specific clues sought at that exact turn, giving us a top positive document and hard negatives to train on. Using this synthesized data, we trained AgentIR-4B. This is a small footprint embedding model, based on the Qwen 3 embedding 4B architecture, that is explicitly trained to align reasoning-augmented queries with highly relevant documents for autonomous research. We trained it using just over 5,200 DR-Synth instances with contrastive learning and LoRa optimization. The results represent a massive leap in end-to-end accuracy. When evaluated on the challenging BrowseCom Plus benchmark, AgentIR-4B delivers a staggering 18% absolute accuracy gain over its base model. Sitting at a 66.27% success rate, it drastically outperforms conventional dense retrievers that are twice its size, not to mention completely blowing past traditional baselines like BM25. Smarter search also means fewer steps and zero overhead. AgentIR-4B significantly reduces the average number of search calls needed to complete a task, dropping from over 31 steps down to under 26. Better yet, it actually beats computationally heavy LLM re-ranking and high DE-style query expansion by roughly 10% in absolute accuracy. And because the reasoning traces are generated natively by the agent anyway, we achieve this with zero additional inference overhead. What's incredibly exciting is its zero-shot generalization across agent architectures. Even though AgentIR 4B was trained using one specific agent setup, its performance gains transfer instantly to other agents, like GPT-OSS 120B and GLM 4.7, without any additional fine-tuning. It works seamlessly across models with completely distinct reasoning styles and search behaviors. Now, you might wonder, why do we only embed the current turn's reasoning trace instead of the agent's whole history? Because the current reasoning is generated conditioned on the agent's entire history, it inherently summarizes past findings. The current turn alone covers over 40% of all past clues, making the explicit embedding of older context highly redundant. In fact, forgetting is a feature, and the current reasoning acts as an implicit curator. If you inject all past reasoning into the retriever, it actively degrades performance. Older turns often contain speculative, incorrect hypotheses that the agent later discarded. The current reasoning naturally organically drops these outdated guesses, acting as a filter that prevents noise from skyrocketing and gives the retriever a much cleaner signal. To wrap up, we believe the future of retrieval is what we call context engineering. As autonomous agents rapidly become the primary consumers of search engines, our retrievers must evolve to exploit explicit machine thought. Moving forward, agent-optimized contexts will undoubtedly drive the next generation of information retrieval. Thank you for watching.